In this, we're going to look at how we can find the pH of a strong acid. A strong base. It's pretty similar to how we find the pH of a strong acid. However, there's something else that we need to consider, and that's the fact that it's got hydroxide ions, not hydronium ions, being produced when it's dissolved in water. So because it's a bit different, I need to give you a little bit of background information. First one I want to remind you of is that water dissociates to become hydronium ions and hydroxide ions. Now, linking this to the equilibrium topic that we did within this same bit of learning, there's a Kc called Kw. The W means water. That's actually what it is. It's the water dissociation constant, and it's really important in what you do next year, and it's vital if we're going to know how to find the pH of a strong base. The nice thing is, we know the pH of this stuff, water, and we know that it's 7. So it means we can actually work out mathematically what the hydronium ion concentration would be in this equilibrium. Because it's got a pH of 7, it's just water. So, you might be able to do it without a calculator. What would be my hydronium ion concentration if the pH is 7? So pure water, nothing else in it. What would be my hydronium? What's our calculation for working it out? Remember that pH is the negative log base 10 of the hydronium ion concentration. How do you reverse that? Good, so it's 10 to the negative pH, so 10 to the negative 7 moles per litre. Okay, so that is its concentration. That's what it is. So that number would go into there. However, there's something else we know about water. Is it acidic or is it alkaline? Neutral, very good. And I've sort of shown that with colours to sort of represent that. It's neutral. So what does that mean about the relationship between these two ions, the acidic one and the alkaline one? They're equal. Okay, they're actually equal. So that means the hydroxide ion concentration is also going to be 10 to the power of negative 7. They have to be the same, or else it would be acidic or alkaline, not neutral. If they're the same, it's neutral. So that's 10 to the negative 7 as well. So if I put those two numbers into here, 10 to the negative 7 times 10 to the negative 7, then what does this Kw value mean? Perfect. 10 to the negative 14. Now it it does have a unit, but we don't worry about the unit in level 2 or level 3 chemistry. Okay, so it's 10 to the negative 14. This is a really important number for you to remember. It's not given to you. You need to know that Kw is 10 to the power of negative 14. 14, that's an interesting number. What did you used to think went up to 14? The pH scale. And that's why the pH scale goes to 14. Okay, because if you do the P function to that, a thing called pKw, not surprisingly, it equals 14. Okay. What it means is that concentration of these two, no matter what the solution is, if it's aqueous, dissolved in water, if it's an aqueous solution, dissolved in water, this times this has to equal 10 to the negative 14. However, in an acid or a base, it's not going to be 10 to the negative 7 times 10 to the negative 7. They're going to be different numbers. So, for example, if I had, and I won't need a calculator for this one, if I had this 0.1 moles per litre HCl, if I have 0.1 moles per litre HCl, then I know that that's going to make 0.100 moles per litre of hydronium ions. Okay. That also means I can find out its hydroxide ion concentration. So if I rearrange this equation here, the one in black, I get OH minus equals Kw over H3O plus. And I know these two numbers. I know them. I know that this is 10 to the negative 14 because it always is. And I know this number because of the concentration of my acid. So I can find it and it ends up being 10 to the negative 14 divided by 10 to the negative 13, 10 to the negative 1, so it ends up being 10 to the negative 13 moles per litre here. Alright. Now, in reality, you're not going to have it going this way. You're going to have something like this. Okay, if I've got a strong base like this, the first thing I'm going to do is show it breaking up into its ions. Okay, so dissolving in water. So the sodium hydroxide makes those two ions. Notice one of these making one hydroxide, so it's in a 1-to-1 ratio. Sometimes it might be something like calcium hydroxide, where one of these would make two of these. And you have to allow for that mole ratio. I'll let you do some examples on that later. So if I know that this is 0.01 moles per litre, so is that and so is that. Which one of these two affects the pH? Not both, no. Only the OHs. Okay, so then I'm going to say, well, I know that my hydroxide ion concentration is equal to this. Okay. Then I'm going to rearrange my equation here in black to be finding my hydroxide ion hydronium ion concentration. Why do I need that according to the question? Find what? pH. So the H is to do with hydroniums. So I need the hydronium ion concentration to answer the question. So this is kW over 0.0100 moles per litre. So 10 to the negative 14 divided by 0.01. If you've got calculators on you, have a go. And your calculators will probably say 1.0 times 10 to the negative 12, or 10 to the negative 12 moles per litre. Then I do the pH, which is the negative log of that number. And it'll be 12.0. Okay. There is another way to do it using a thing called POH, and POH and pH add up to 14. So that old adage about 14 is still useful, it's just not quite correct. Okay, and that's because that's what we call the pKW. It's probably a more useful rule to use in level 3 than in level 2, so I'd rather use this process in level 2. So just go through the process for finding the pH of a strong base. First we'll show it breaking up so you can see how many hydroxides are made by each one of those. If it's 1-to-1, then that number is just that number there. If it's not, then you have to multiply it by whatever's in front of the hydroxide. So if there are 2 hydroxides made, it'd be 0.02, for example. Once you know that, you can then substitute that into this equation here, which is this one rearranged. Once you've got the hydronium ion concentration, do the negative log of that to get your pH. Okay. Because there's so many mathematical steps in it, you know that these answers are going to be around your merit level rather than just achieved, which will be your pH of your strong acids. Are there any questions before I turn that off? Awesome.